Perfect, great, thank you. Thanks for joining, everyone. Welcome to this third part of this calibration and profiling webinar series. Today, we'll be talking about managing unique substrates and backlit materials. Presenting today is Ray Chadler, Portfolio Manager at X-Rite Pantone. I'm Netta Goldfriend, a Regional Marketing Specialist for EMEA, and I will be moderating today's webinar. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have questions, please use the questions function on the GoToWebinar panel. We will have time to answer some questions at the end. Finally, this webinar will be recorded and you will receive a link so that you can review the webinar at your convenience. I'll now turn it over to Ray.
Thank you. So I'm going to go through this hopefully relatively rapidly, but if I jump over something that's of interest, of course, you'll have a chance to answer or ask questions at the end. So let's see if I can get this moving. There we go. So I have challenges in managing color. What this really is a question of how we see color with our eyes. A lot of these questions are how we see color with our eyes and how we see them when we're measuring them. So we have different issues with texture and whether we've got reflections and the environment we're in, so whether we see fluorescence from a lot of the materials, and then also how we, from a big picture, see things as very consistent, but if we look too close, the consistency goes away. And then, of course, as we move into things like signage and backlit displays and things like that, we have issues around transparencies and other issues with backlights. So, and then of course we have change, right? We have changed in textiles. So there's a lot of different kinds of textile devices and processes. It used to be, I would say, in much of when we talked about digital textile printing, it was mostly about dye sublimation. And now there's a real surge in direct-to-fabric printing. And then this whole shift that are interesting times now is probably accelerating, which is industrial printing of textiles so that we get short-run clothing or very customized clothing. I was on a seminar yesterday where someone was talking about, things that were the actual garments were being customized very directly for every individual customer. So lots of things like that affect the way we have to measure and what kind of things we do. So, some of the considerations in measurement are aperture size, and we'll talk about that in a second, but it's really about, what we've done traditionally in regular ink on paper or toner on paper. Aperture size really has some different impact when we think about particularly textiles, but even when we look at things like backlit vinyls and things like that. And then instrument geometry, what we've done in traditional parts versus digital printing is different. And then what M mode or what measurement mode we should be using. And I say this might be a trick question because we'll see it's really not a simple question. In the graphic arts, there's a defined primary measurement mode that's used, but today, depending on what you're doing, there may be different reasons to use different modes. And then, do we want to spot measure these? Do we want to scan these? Do we need to average them? All of those kind of things. So we'll address that a little bit too. And then, of course, my favorite is what about tricky substrates? So these canvas or textured fabrics. We had a support call last week about what about measuring on glass and backlit glass, different kinds of plastics, and then all sorts of other backlit materials. So let's, do a little bit of history and some basics here. Classic paper measurement done in the graphic arts is done with a 045 or 450 measurement device, right? So a couple of examples over there on the right, but the concept here is pretty simple. You have a receiver up at the top or where those lamps are, so 045 or 450, and then lamps that essentially flood with illumination, either from multiple angles of lamps or with some sort of ring illumination. And this is pretty common to the way we look at things on a day-to-day basis, where we've got our eyes in one spot and then illumination in another place. So this is pretty classic for measurements, the ISO standard really for measuring ink on paper. But when we look at things with a lot of texture, we've used a different kind of geometry. And traditionally, when we looked at printed fabrics or fabrics of any kind really that were not digitally printed, we've measured those with a sphere instrument. And a sphere instrument is different in the sense that it uses this big globe of illumination to get very soft illumination on the piece being measured, and then can have a couple of different ways of capturing data from it, you know, with the included spectral or specular reflection or not. But it gives a different look to the instrument when it's measuring. And so this has been traditional for textiles, you know, for years. And so, and I should mention in that last slide too, is that traditionally in textiles, they used a pretty large aperture, right? So if we look at this though, digitally printed fabrics have been mostly measured with 45-0 geometry. So this is partially a carryover from other digital print processes, where the idea is, you know, this mimics what your eye sees, like I was saying before, and it's the tools that they had, right? So if they were using the same printer to produce a reflective poster and a backlit poster, they would use the same pieces because those were the tools they had. But you know, some of the things that we see is, you know, having a larger aperture is useful, and we'll see why that is in a second. So people have been using, say, an X-Rite with a 6mm aperture, or an i1 Pro 3 using what we call a virtual aperture, which is where we're scanning across, and we can see on the illustration on the right that we're capturing multiple pieces in every patch and then averaging those together. And that helps, you know, integrate in some of the texture effects from illumination. And so, and also deal with consistency, where the instrument with a smaller aperture can see more inconsistencies than our eye sees backed off. So, and then the other plus then is moving something like the i1 Pro 3 Plus, which has a much larger aperture, and that larger aperture integrates just in spot mode, but then you can obviously understand that if we scan with it, we get even more integration for a better measurement on textured pieces. So what's all this business about apertures anyway? And so I'm looking here at a series of apertures, and you know, the most common size aperture in the graphic arts of a graphic arts handheld is either 2 or 4 millimeters. And many people in the graphic arts like to use a small aperture because that can minimize the amount of area taken up by control bars, and so it minimizes waste, and that seems good. There's some issues even in traditional print about matching the aperture size with line screen and things like that to make sure that we don't miss information that way. But traditionally a 2 or 4 millimeter in ink on paper works out reasonably well. But as soon as we go to a textured sample, right, we can start to see where this may be a problem. So we put in this texture here, and we can see that if I look at 1.5 millimeter over here, you know, I may be seeing more darkness than light, right? So I may be getting a very poor sampling of the material. As we go, we can see that we get better sampling overall with the larger aperture. And this is both, you know, a plus from the side of getting this better sampling, but it also provides more light. And usually providing more light to a measuring device is much like trying to read a paperback in a room with the light off, or, you know, with a good reading light next to you. So, and then last, you know, here we can see that, you know, we're getting 28 times the area with an 8 millimeter aperture than we would, you know, with a 1.5 millimeter aperture. So you can just get an idea of how much more averaging we're getting to take out issues of consistency and texture and so forth. So, you know, in this world where we're using non-smooth substrates and potentially also using imaging that may be coarser than normal because we're going to be wrapping a building with it, for instance, so no one's going to get up close, moving to a large aperture is often a good solution. And then lighting. We all sort of know intuitively that different lighting creates different results. So we have some nice adjusted pictures here with spectral curves of the lights, and we can just see, right, what we really know is true. Our eye has a great job of making at least 3 out of the 4 of these look pretty much the same when we move from a room to a room. But the reality is that the pickup and the relationship of the colors on the page can change pretty dramatically. So understanding the lighting that you're viewing in is going to be very important, and that leads us to why the creation of these different measurement modes was done. Traditionally, years ago, we used mostly spectrophotometers that used Illumina A, and that's largely a carryover from the fact that the original ISO specification for densitometry made Illumina A a requirement. And so as we needed to have actual control over color as opposed to just ink laid on, we took those same requirements and brought them into spectros. The problem becomes, what about fluorescence? So fluorescence created a real problem, and there was a real problem in matching proofing that had fluorescence and printing papers that didn't, and trying to figure out the characterization of that. And that had to deal with both the lighting that we used in our viewing booths and the lighting that we used in our instruments. So M1 came across to be D50, which is the standard in the graphic arts. And there's 2 parts to that, which we don't really have to worry too much about in this sense, but one is a pure D50 match, and then one is a response that's really just to do with optical brighteners and optical brighteners in paper specifically. And then there was something that has been used a lot in the photo industry, which is UV cut. So where we take the UV energy out of the lamp, and there's UV energy in both Illumina A and in D50, more in D50. But this takes away the issue of fluorescence, which is much like what your eye does, right? So if you're viewing a sample independently, so not side by side or not next to a merchandise being illustrated or something, then many people use UV cut because this way they're getting pure color information and they're not worried so much about the substrate. And then polarization. Polarization has been used for a very long time in densitometry in Europe, and but polarization was never a ISO standard, particularly for measuring color, until these M modes were coming along. And polarization then is very defined and also includes a UV cut piece. And we'll see in a minute where polarization plays with some of these new things. But I find that most people find everything I just said very confusing. So this is my shortcut, right? Is I'm a visual guy, and so M0, it's a light bulb. It's like our old lights before we moved into fluorescence and LEDs. M1 is essentially to imitate the sun or something like it. M2 is to protect us from the sun, so we put an umbrella there and we cut out that UV. And then M3 is polarized, much like our sunglasses, which also have a UV cut perspective. So, for me, those visuals help shortcut what the major definitions are. So let's see where it goes. Polarization. One of the cases here is, where I said texture and gloss, but the real big one is micro highlights. So micro highlights come from texture and usually ink being applied on top of that. So the most common place we see this in digital imaging is in canvas and in some fabrics, where we see this micro highlight effect that hopefully you're seeing on your screen. And this has an interesting effect when you measure it, because your eyes have the ability to sort of throw that out, if you will, right? They can see that, and they see the purples, they see the oranges, and they can sort of discount those white highlights that are inside of there. The problem is an instrument sees it all, right? It's the all-seeing instrument. And so if we look at a gamut plot of an ICC profile, what we see is we've lost a lot of information in the low end. So that whole space between those yellow and that horizontal yellow and blue bar till we see that gamut cloud up there is basically because all of those darker colors were polluted with those micro highlights. So we have, lots of highlight information, but we've lost our shadow information. And so, if we put in polarization, what happens? Suddenly we're gaining back a lot more information down in that low end. And the concern generally about this approach is, well, first of all, that it's scientifically not correct. Well, I tend to be very practical, and what I've seen is that the effect of doing this gives me a result that makes my profiles better. And one of the reasons of concern, right, is that we've lost some highlight gamut here, but this is not real highlight color information. This is really the highlights. And so the nice thing is the highlights have never actually changed, right? Because your highlight is the substrate, the white paper. And so that has maintained the same. But we've picked up all of this volume of colors that were affected by those micro highlights. So again, when we're looking at texture, and sometimes in gloss materials too, where the gloss is just obscuring that as well, we find that polarization can really make a difference. And so that's a big thing to understand when you're getting into some of these new materials. So we've talked a little bit about glossy, a little bit about matte, but we can see that, that reflection is, with glossy, it's pretty straightforward, and that tends to work well with 045. The matte object, not quite as well. That's why we've often used that sphere geometry, but we can see still with a larger aperture and capturing that we can do some good things, right? But is that all? And the answer, of course, is no. So there's also transmission. So when we look at transmission, then we have to look at some of the same things, right? What's the aperture size? What kind of material are we measuring, right? What's our end use? Because that end use is really a production question. But then the definition of the light. Is it D50 or is it something else? So, in the, so those are concerns, but one other concern is, when I was talking to someone about controlling backlight and setting some expectations, and I realized that they weren't talking about this. They were talking about this. We're not talking about this. We're talking about the process on the left. The process on the right is a whole different game, and we're not going there today. And years ago, right, backlit media was smaller in types that were available. They had film, Duratrans, which essentially was a photographic process, still available today, that had a built-in diffuser, and then a little bit of inkjet or toner-based kind of material. And the instruments of yesteryear, right, used a fixed backlight, and then you move the sample around to go do that either automatically or manually to capture that data. But part of that was successful because of the kind of relatively straightforward materials that were all similar in nature, that worked relatively well. Today, there's a little more challenge. So just in backlit signage alone, right, I'm looking here and I'm going, this is a test I often do. It says, which one is this a video? Which one of these are Duratrans? Which one of these are vinyl? Which one of these are fabric? So right there, I look at this and I go, I don't know. Right? Well, I do know, but so the answer here, first of all, is that I cheated. There is no video here because we're talking about measuring stuff that we print. But it's very hard to tell here just from this 10,000 foot view what the material is, but that means that they've successfully captured the issues that are behind each of these particular materials to produce this, because they've gotten past the issues that each one of these materials has. So yeah, we're talking about translucent or transmissive, and now we're really talking about moving from what was largely a photographic process to mostly digital printers. And there are lots of different ways of printing processes, aqueous, solvent, UV, more and more. But it's one of the things that goes on is as we start mixing media and printers, and particularly as we go across processes where maybe we have both reflection and transmission, custom calibration profiles becomes an even bigger issue. When we look here just at backlit media, there's film, there's polyester, there's, PET, there's polycarbonate, there's fabric, there's Lexan, there's glass. Oh my. And then we have new fine art media. This is not new fine art media, but this is a story that is important for all of this, right? Which is understanding the media and inks. So this is a media that is compatible with the inks that we see. However, the side of the media that it was printed on is not compatible with those inks. So it's cool looking, but it wasn't the intent. So if you had flipped the paper over or the material over and printed it, you would have gotten a test chart. Instead, what you got was fine art. So this is really just a caveat, a warning about making sure that you have all of the parts of the process in control. This is an obvious failure, but smaller failures exist, and knowing the whole process is important. And then the question is, what's new in backlight, right? So, we all know that the trend in the whole world is to move to LEDs, but that's not true necessarily because there's a huge installation still of other kinds of backlights, mostly fluorescents, but lots of different kinds of LEDs too, whether it's edge lit or backlit, and where the LEDs are sourced from. I was at a sign show a year ago or so, and at the sign shows, if you've ever been there, there are rows of LED vendors all talking about their beautiful daylight LEDs, and it's like watching a rainbow. Their daylight is not the same. So, that becomes an issue. So, I did a quick test of backlit sources in my office, right? So I have a much older viewing booth here that has both reflection and transmission. And then I have a new viewing table in the center, which is state of the art. It's fluorescent, but it's, it's state of the art fluorescent. And then I have what is often used in retail signage are these light LED edge lit boards that are very inexpensive. So this looks great. And you can say, oh yeah, they all look pretty good, pretty even, so forth and so on. But what we have here is a picture of that left-hand light booth and the right-hand LED tablet, right? So that's if I normalize the white balance for that fluorescent, then the brightness level and the color of the LED is pretty different. And it's mostly, frankly, it's mostly a brightness level. But still, we can understand that if we're trying to characterize signage that's going to go on one versus the other, this becomes an issue. And if you're familiar with spectrographs, it's even more so. Those two fluorescent booths, even though there's 20 years of age between the two, have very similar spectral curves, though different brightness levels, primarily based on age. And that LED, source at the bottom has a very different spectral curve, and as we saw before, much lower luminance. So this is why, being able to actually use the backlit of the intended destination is sometimes a really big deal. So this shows, the idea of getting those different backlits and doing a quick profile of them starts to bring those things in much closer harmony. And this becomes really important if you've got signage in a store and it's signage that's going to be replicated, and it may be replicated against different materials or different parts of, different backlights. So this is, again, where having control of your backlit light and being able to actually characterize individual backlight situations may become very important depending on your use case. And then last piece here really is, are you using this during the day? Are you using this at night? Are you using both? Right, this is actually one of our bigger challenges. So single layer printing, which means printing once on the surface of the material, gives us this result on the far left. But if we backlight that, that it will look great during the day, we tend to blow it out at night. Double layer on the front tends to be a little too dark, but maybe okay. Double layer at night looks very good. And so often, if you have the capability in your RIP, you can double layer on one side of the media and on the other side. So you get rid of this effect of being too dark during the day. But this is a challenge, and you need to understand both your whole system capability at that point. You know, how can you register across that to get the best result in a day and night situation? And then, as I said earlier, you know, we had this question about measuring on glass earlier last week in our support lines, right? And so, and again, this is a little tricky, right? Because in the perfect world, you should measure glass the way you're going to look at it. Makes sense. So if you have a diffuse light source on one side and the measuring instrument on the side of the viewer, it's great. That works really well if the print side is towards the instrument, right? You don't have stray light, whatever kind of weird stuff the glass does, you're capturing, all of that is great. The downside is if it's printed behind, so it's towards the diffuser and you have the glass in between the instrument and the material. So this means that the thicker the glass, the more the light scatters before hitting the instrument. And this is sort of like that micro highlight story, in that it often makes the dark patches appear lighter to the instrument. If you're in this situation, so the glass is very thick, polarization doesn't solve this problem, the micro highlight, because it's not a micro highlight problem, but it's a diffusion problem. This may be a case where actually reading it the wrong way, which is measuring it backwards so that you're getting the effect of the glass and the patches by having the patches towards the instrument, may still give a better answer. But if you're doing it that way, you have to flip the chart before you image it so that it will match up with your profiling software. So I've talked a lot about materials and how to measure them and worry things. So I'll just give you a quick little story here about what the i1 Pro 3 Plus is, right? So this is a relatively new instrument from X-Rite, and it's designed specifically to answer a lot of the problems we talked about. Large aperture, offers polarization, doesn't require it, but it offers that as an option inside of there, and it's built into the kit. Single pass scan, so no more multiple scans for different kinds of M modes. And it does this by having a full spectrum LED source that can do all of the tricks of all the M modes, 0, 1, and 2 in a single pass, or put on the polarization filter and get polarization measurements. So there's some other tricks though that are really important, right? Make sure that the material is really anchored and dimensionally stable. Not so much of a problem for most backlit other than backlit fabrics, but for all of these other textile materials, this becomes very important that we actually lock that down. So I mean, in the picture down here, you know, we've actually got magnetic bars to go stretch materials and hold them dimensionally stable down there. Again, you know, using a wide measurement aperture or sphere geometry gives us more information by gathering more light in the transmission side, and deals with, you know, consistency, you know, whether there's variations across the patch, as well as texture issues. And then, you know, M1, if you're trying to capture the fluorescent effect, M2 to kill the fluorescent effect, and M3, you know, primarily to get rid of those micro highlight problems. So, you know, I guess my last parting words before you can ask some questions is nothing stands alone, right? So, you know, we've talked a lot of things, but you know, remember that if it's day night, we have to understand what the RIP's capability is. You know, if we printer and materials, we have to make sure that the printer and materials match, and that we're actually imaging on the right side of the material. Knowing the lighting that we're going to be in becomes important. You know, all of the environmental considerations, and then how you're going to measure. If you match this all together, you get great results. If you start to not consider that, then we start to add more variability in the system, right? So, and this becomes really important, right? When you look at your market, do you need to match backlit and reflection prints, or backlit and, you know, product sitting on the table? Is it indoor or outdoor? That may have a question about the kind of both the material and the printing inks that you're using, or the kind of printer you use it with. And then two-sided or one-sided. And then really, you know, I'll circle back to the top in the bottom, which is you really need to understand your whole process. The new print methods that are out there, and then I think you can see how custom ICC profiles with the different media and inks can really help your business. So from that, I'm ready for questions.
All right, thank you, Ray. Okay, so if you have questions, you can submit them now in the questions panel. In the meantime, I will pop up another poll question while we wait for the questions coming. Okay, thank you. We have some questions that came in. You can still continue and submit your questions. So Ray, one question is, does the i1 Pro 3 and i1 Profiler allow us to predict ICC profiles for illuminants other than D50?
The answer is yes. It allows for a couple of different methods to do that. One thing, it allows you to actually measure some other illuminants and use that as part of the process. It also gives you some presets that are inside of there. And it also, if you have a measurement of an LAB, it actually lets you do, maybe not quite the same thing, but important in some ways, lets you do ICC white point adaptation. So you might think of that as a not quite different illuminants, but a way to get to the same path. But in the end, right, because it's still delivering ICC version 2 or 4 profiles, it does all that magic in the background because it's capturing spectral data, but then it's doing it inside the space, the wrapper of D50, because that's the requirement of that specification.
Okay. Another question we have is, can you say anything about the I1IO table development for backlight media?
So I think that the question is asking whether, we are offering an I1IO3 table with a built-in backlight. And what we found is, for most of our people who are really doing backlit, is that when we were doing our initial research, is because if we saw that screen up front, how those different backlits, how different their color was, that people were asking really for us to be able to characterize their media with their backlit. Particularly, a lot of sign providers now are building their own backlit displays, and so that they build their own backlit device for the I1IO3. And we've actually built spacers for the I1IO that can raise it up so it can accommodate thicker tables and things like that as well. So, the concept right now is to you bring your backlight, so to speak, and that will provide the best answer and the closest measurement to what your final intended use is.
Okay. And I think one more question we have time for is, for textile printing, we use D65. In this case, do we use the same rule to choose the M model?
So there is no D65 M mode. So in that sense, D50 is probably as close to D65 as any of the options there. But I think in this case, the question is the D65 often used in measuring textiles is not the source D65, but it's a colorimetric calculation. And so the colorimetric calculation can be done off of the spectral data that we capture in I1 Profiler, and then you can use D65, or you can bring in D65 measurements into the software and build profiles that way as well. But in the end, building an ICC profile today, unless we go to something outside of the spec that's widely supported, still says in the end, the profile is going to say it's D50, whether it was built with D65 or something else. But we can certainly accommodate that as well.
Okay, thank you, Ray. That was the last question we have time for. Again, we will follow up if we didn't get to your question, and you will receive an email with a link to the recording of this webinar. So thank you for joining, and have a great day. Thank you.
Thank you.